Good evening, dear all. We shall continue the dimension analysis topic of class 11. We have already learned how to write the dimension formulas and dimensional equations. Now today we will learn the applications of dimensional formulas. Okay, now what are they used for? That we have to know. Otherwise, just writing the units would be enough. So the first use or the application of the dimensional analysis is to check the dimensional correctness of the equation. Another word for correctness is consistency. So the first application is to check the equation's correctness, consistency. Okay. Next application is deducing. Means what? Forming the relation between various physical quantities. So what is the relationship between physical quantities, or how can we develop a relationship between physical quantities? That is what is the second use. Fine? Okay. So now let us talk about the use number 1 in this video today. Fine? So let us talk about how to check the dimensional correctness of an equation. For that, we use the principle of homogeneity of dimensions. It is a principle. Okay? It is a rule. Fine. This is the principle we are going to use to check the correctness of any equation we come across between various physical quantities. Fine. Okay. Now what is this homogeneity principle of dimensions? See, in our daily knowledge we know that suppose I want to add mass to some other physical quantity. To which physical quantity can I add it? I can add it to mass only. Correct? I cannot add mass to length. That is not possible. I cannot add mass to time or length to time. That is not possible. Same thing I cannot do with subtraction. I cannot subtract mass with length or length with time. Not possible. I can not equate mass to time, length to time, length to current. I cannot equate. So, what is this principle of homogeneity? It is saying us that we can add, subtract or equate same physical quantities only. Now using this principle of homogeneity, remembering that we can add, subtract or equate same physical quantities, we shall check the correctness of the equation. For that, let us consider one simple example which you have learnt in 9th standard, in 10th standard, equation of motion. Let us consider whether that equation is correct or no using the principle of homogeneity. So what is the first equation? V is equal to u plus at. This is the first equation of motion known to us, where v is the final velocity, u is the initial velocity, a is the acceleration of the body, and t is the time taken. So we will understand separately each of the term, and all the terms must have the same dimensional formula, then the equation is correct. What is the homogeneity used here? We can equate same physical quantity. We can add same physical quantity. If I bring 80 this side, we can subtract same physical quantity. That is what we are using here. So first let us find out, or let us write the dimensional formula. Remember, dimensional formula always we have to write in the square bracket. What is the dimensional formula of velocity? m0 L1 t minus 1. This should be in your memory. Okay. Same will be the dimensional formula of u because it is initial velocity. What is the dimensional formula of a? A, acceleration, again m0 L1 t minus 2. Okay. Next, what is the dimension formula of t? Capital T raised to 1. I can write m0 L0. Okay, because m and L are not having any dimension in time. So these are the variables, the physical quantities in this equation. V, U, A, T, V, U, A, T, all dimension formulas I wrote. Now the first term is V. So it is having this dimensional formula. Second term which we are talking about. This is the first one, this is the second one, this is U. Same dimension formula. Now let us check whether AT also has the same dimension formula as the velocity. Because we are equating velocity, then that side also should be velocity. If LHS is velocity, RHS also must have each term as velocity. That is the meaning of checking the correctness of the equation. So V has the dimension formula of velocity, U has the dimension formula of velocity, AT also must have dimension formula of velocity only. Okay, then the equation is correct. Whether we are equating or adding or subtracting the physical quantities. Fine. So let us check whether AT together gets us the equation of velocity, because one side of the equation is velocity. Understood? So what is A? m0 L1 t minus 2. This is from our memory. T is t raised to 1, m raised to 0, L raised to 0. So adding the exponents, because the base is same, m has 0 plus 0, so 0. L has 1 plus 0, 1 plus 0, so 1. T has minus 2 plus 1, so minus 1. So what is my answer? AT's dimension is equal to m0 L1 t minus 1. Agreed? So this was our first term, this is our second term with the dimensional formula of velocity. Our third term, which is AT, also has the dimensional formula of velocity itself. So our equation is correct. Agreed? Yes, am I clear? Okay, so this way we can check the dimensional equations correctness. Let us do some few more examples, and then within this same video, after checking the correctness, with the help of checking the correctness, what else we can find out? What else we can do using the principle of homogeneity, that also we shall do. So keep watching the video till the end. It is interesting if you remember and understand. And JEE and NEET dimension analysis, formulas, checking, are definitely asked. This is a very important topic of the entrances. So just don't take it lightly. Fine. So now let me try some more examples. Okay. What are those some more examples? S is equal to ut plus half at square. What is S? S is the distance. This is the equation of the motion 2. Okay, so S is equal to ut plus half at square. What is the dimension formula of S? It will be L. Okay, M and T, if you want to write, you write. Otherwise, you can leave it like this for this type of a question. For other type of question, don't do like that. You can even write M0, L1, T0. But be very careful while writing. One small mistake in writing the power, your whole answer will go wrong. Fine? Okay. Now, what is ut? I am just writing directly the term 1, term 2 and term 3. So, ut. So, first I have to write u. What is u from the memory? What is the dimension formula of u, initial velocity from memory? M0, L1, T minus 1. And T. T is already known to us. M0, L0, T raised to 1. Now, what should my answer be here? M0 plus 0, 0. L1 plus 0, 1. T is minus 1 plus 1. Just see very carefully, you see. Minus 1 plus 1. Here the power is minus 1. Here the power is plus 1. The answer becomes 0. That is the power of T. So finally, what do I have? I have M raised to 0, L raised to 1, T raised to 0, which is same as equation 1, term 1. So, I am ready with term 1 with dimensional formula, ready with term 2 with the same dimensional formula as term 1. Now, let me talk about term 3. What is my term 3? Half at square. Now purposely I have written half here. What should I do with that half? Nothing. It is having no dimension. So leave it as it is. Only I will consider the physical quantities. What are the physical quantities? A. What is the dimension formula of A? By memory. See, if you practice all these dimension formulas, you will remember. Okay, so keep practicing. That is very important. So this is A, dimension formula of A, and T square. T square, M raised to 0, L raised to 0, and T raised to 2 because T square. Okay, so let us work this out. M raised to 0, L raised to 1 plus 0, 1, and T raised to minus 2 plus 2. So what is my answer? T raised to 0. So what is my final answer? M raised to 0, L raised to 1, T raised to 0. This is my third physical quantity or the term as shown in the question. All the three have the same dimensional formula. So is this equation correct? Yes. Understood? Okay. So by different examples, we can keep doing such type of questions to check the correctness of the equation. One more we shall do. Then we will go to the other type where we can understand how to use this principle of homogeneity and find some other values. Fine. So now let us take another example in which there is a physical quantity which is written and derived in your textbook appendices. Okay, as I said in the previous video, there are many formulas of dimensions which are derived in your textbook last pages appendices. So from that, please learn them very quickly so that you understand how to go about with this dimension analysis. Fine. Now here V is the velocity of the satellite, orbital velocity of the satellite with which you can make the satellite move in the orbit around the planet, that is Earth at present. Fine. So V is the velocity. Okay. G. What is G? G is the gravitational constant. What is its dimension formula? This is also from memory. So remember it and derive it from the last pages of the textbook. Fine. G. Then M. M is the mass of the planet. That is, we can take it as the Earth. So M raised to 1, L raised to 0, T raised to 0. This is the dimension formula. Okay. R. R is the radius of the Earth. So M raised to 0, L raised to 1, T raised to 0 we can put. V. V is the velocity, orbital velocity or any velocity. M raised to 0, L raised to 1, T minus 1. These are the dimension formulas of the various physical quantities available in our formula. Now this is there on one side of the equation. So other side we should derive here. This particular formula does or equation does not have terms like the previous two examples. It has only one expression. So that expression should be equal to this. That's it. Our work is over. Fine. So what is the expression? Now this expression has one power. That's why I have taken. Previous also 80 square, one power was there. Here also one power is there. So overall we have to write the power for the whole expression as half. So slowly we will do our work. Very carefully you do so that you make no mistakes. Fine. Okay. 2, as I said, it is a constant, so I don't need to worry. G. I am writing G from here. M raised to minus 1, L raised to 3, T minus 2. I am writing M. M raised to 1, L raised to 0, T raised to 0. Now root is there up, numerator also, denominator also it is there. So overall I will write half. I can write overall for both also, but convenience we'll see what to do. Now R. R is the distance. So M raised to 0, L raised to 1, T raised to 0. Fine. I'll put a power half for this also. Okay. So now let me multiply these two. What is the multiplication? Adding the powers. Minus 1 plus 1, 0. M raised to 0. L raised to 3 plus 0. L raised to 3. Okay, it is not, it is 3. Then T raised to minus 2. T raised to minus 2 plus 0. So T raised to minus 2. Now what should I do with half? Keep it as it is. What should I write down in the denominator? Same. Okay. You can do it at a time also, because in the exam you will not have speed if you do one by one like this. Fine. So doesn't matter. If you are fast, you can do. I am teaching, so I will go slow. For a teacher, slow and steady wins the race. For a student, speed and accuracy will win your race. Okay? Chalo. So now let me subtract the numerator to the denominator. Okay? And write M0 minus 0, 0. L3 minus 1. 3 minus 1, that is 2. And T minus 2 plus 0, negative 2. Now I have subtracted, because both the powers are half, I will put half. Okay. Now when the power is outside, you have to multiply. So let me multiply and see. Okay. So what should I do? M 0 multiplied by half 0. L 2 multiplied by half 1. I will write it. T minus 2 multiplied by half, that is also minus 1. Okay, so finally what am I getting? M raised to 0, L raised to 1, T raised to minus 1. This is the dimensional formula of the other side of the equation. Is it clear? Which is exactly same as that of the velocity. See, this expression is same as this expression. So, is this equation correct? This expression is same as this expression's dimensional formulas. So, is this equation correct? Yes. Understood? Okay. So, very coolly, calmly write down the correct dimensional formula. Most of the students write down the wrong dimensional formula in the beginning of the step itself. In dimensional analysis, if the beginning is wrong, the end is wrong. Remember that. Okay. So I'll just move and you take a pick. Fine.